Hello viewers, I'm Kausalya. Today we are going to solve the problems based on purely resistive, purely capacitive and purely inductive circuits. Right. So the first problem is a voltage V is equal to 100 sine 100 pi t is applied to a circuit consisting of a pure resistor of 20 ohms. So here we are having a circuit with a supply voltage of this value and there is a resistor whose value is 20 ohms. Right. So find the following quantities. The first one is maximum voltage, second one is frequency of supply and the third one is expression for the instantaneous current. Right. So first write down the given data here, that is voltage and the resistor value. Now we are going to compare this expression with the standard expression. So here the standard expression is V is equal to Vm into sine omega t. So now when you compare these two expressions, here the value of Vm is 100 and here in the place of omega I am having 100 pi. Right. So when you equate, you see in the place of omega I am having 100 pi and omega is nothing but it is 2 pi f. Right. So here pi and pi cancel each other and the frequency is 100 by 2 which is 50 hertz. Right. And now the next thing is expression for instantaneous current. So current is given by the expression I is equal to V by R and here this is your expression for V and this is your value of R. Right. So this 120 cancels each other and therefore the value of current is 5 sine 100 pi t. Right. So now our problem gets over here. You see we have calculated the maximum voltage, that is V is equal to Vm. Vm denotes maximum voltage. Here Vm is 100 and the next one is frequency and finally the last one is expression for instantaneous current. Now we will proceed with the second problem. The problem is an inductive coil has negligible resistance and inductance of 0.1 Henry. So here you see negligible resistance, that is no need to consider the resistance here. So we can assume the circuit has only inductance. Right. Now it is connected across a 220 volt 50 hertz supply. Find the current and power. Also write down the expressions for instantaneous applied voltage and current. So here you see we are having an inductance of 0.1 Henry. We know the supply voltage, we know the frequency. So we need to calculate what is the current, power and instantaneous voltage and current. Right. So here the things which are given in the problem are L is equal to 0.1 Henry and here this voltage is nothing but RMS voltage. Right. So VRMS equal to 220 and here the frequency is 50 hertz. So this is an inductive circuit. Right. So what is the expression for voltage across an inductor? It is given by I into XL. Right. If it is a resistive circuit, we will be using IR. Since it is an inductive circuit, here we are using I into XL. Therefore, I is given by I is nothing but V by XL and here this XL is nothing but it is L omega. So just substitute the values. So V is 220. So 220 divided by this L into omega. Right. Omega is nothing but 2 pi f. So the value of L is 0.1 into 2 pi into f is 50. Right. So when you solve here, we are getting the answer as 7 amps. And the next one is we are going to calculate the power. So power is given by VI cos theta. Right. So theta is the angle between your voltage and current. So here we are considering an inductor as a load. That is the circuit is an inductive circuit. So what will be the angle between voltage and current? It will be 90 degrees. Right. Either leading or lagging. Okay. That is not the problem. So here the angle is 90 degrees. So just substitute the values and here the value of W is equal to 0. Right. And the next one is we are framing the expressions for instantaneous voltage and current. So instantaneous voltage is given by, you see the standard format is V equal to Vm into sine omega t. So how to find Vm? Vm is nothing but root 2 times of V. So root 2 into Vrms gives the Vm value, that is 311 volt. Right. And the next thing is we need to find this omega. So omega is nothing but 2 pi f, right? And here the value of f is given in the problem as 50. So just substitute the values and here the final answer is 314 radian per second. So the expression for instantaneous voltage is V is equal to Vm into sine omega t. So here Vm is 311, sine the value of omega is 314 t. Right. Now we are going to find the value of current. So the expression for current is, you see, I is equal to Im into sine of omega t minus pi by 2. Because this is an inductive load or it is an inductive circuit. So here the current lags the voltage by 90 degree. Therefore here it is given as minus pi by 2. Right. So how to find Im? Im is given by Vm by XL and this XL is nothing but 2 pi FL. So Vm is 311 divided by 2 pi into 50 into the value of L is 0.1. Right. So when you substitute here, the answer is 9.9 amps. Again, we had already calculated the value of omega. Right. So just substitute it in the expression. So I is given by 9.9 sine of 314t minus pi by 2. Right. So second problem gets over here. We will proceed with the third one. So in an AC circuit, the applied voltage is given by V is equal to 200 sine 314t and the expression for the leading current is given by I is equal to 10 cos of 314t. Right. So voltage is given, current is given. Find the circuit constant and find the power factor of the circuit. Draw the phasor diagram. Right. And here you see it is given as leading current. Right. So what do you mean by leading current? We are having a capacitor in the circuit. Right. So first write down the expressions for V and I. Right. You see one is in sine form and another one is in cos form. So it will be better to analyze if we have both the voltage and current either in the form of sine or in the form of cos. Right. So we are rewriting the expression for current. So here in the place of cos 314t, here we are writing it as sine of pi by 2 plus 314t. Right. So again you see 10 sine, we are just rewriting 314t plus pi by 2. Right. Now we are going to compare our equations 1 and 3. So when you compare your equations, you see here it is evident, right? Here it is 314t, here 314t plus pi by 2. So what does it tells us? This tells us the circuit is purely capacitive circuit because this current leads the voltage by 90 degree. Right. So therefore the circuit is purely capacitive. Now from the given expressions, you see this is your expression for Vm and this is your expression for Im. Right. Now we are going to calculate Xc because it is a capacitive circuit. Right. So Xc is nothing but Vm by Im. Right. So just substitute the values and here the value of Xc is calculated as 20 ohms. The next thing is, again the other formula for Xc is, it is 1 by omega c. Right. So Xc is 20 which is equal to 1 by omega c and here this omega is 314. Right. It is evident. It is given in the problem. So from this just calculate the value of c. So here the value of c is calculated as 159 microfarad. Right. Now the next thing is power factor. So power factor is nothing but cos of pi. So here the value of pi is 90 degrees. So again cos 90 is 0 degrees. Right. Now we are going to draw the phasor diagram. So to draw the phasor diagram, we are calculating the values of V and I here. That is Vrms and Irms values are calculated. So here Vrms is Vm by root 2. We know Vm. So just substitute and find the value. And the next one is I. I is Irms is Im by root 2. So just substitute the values and here it is 7.07 amps. Right. Now we are going to represent this voltage and current in polar form. So here a polar form will have a magnitude along with an angle. So here the voltage value is 141.4 with an angle 0 degrees, and here the value of current is 7.07, but it has an angle of 90 degrees, right? That is, it leads, therefore plus 90 degree. So how to represent it in phasor form? You see here we are having a voltage V, and this current leads the voltage by 90 degrees. So here we are having a current I, and the angle here is pi by 2, that is 90 degrees. So here the current I leads the voltage V by 90 degrees. Right. So here comes the end of this problems. If you have any doubt, let me know in the comment section. Thank you.